Hi, my name is Chris Gomez, and I work at Kobe University. And today with Yuichi Hayakawa, we are presenting the results or some of the preliminary results of this research called Peri-Urban Mountain Soil Compaction and Erosion from Pedestrian Traffic. Now, if you are the JPGU and you are watching this video, it means that I'm either trapped in traffic or trapped in a very important meeting where we discuss the future of humanity. So I'm sure you understand that I can't be with you this morning. So I will be at the poster session tonight. If you have any question regarding this presentation, do not hesitate to come and see me there. So, where did the work take place? Well, not so far from where I am now, in Kobe, actually near my house, in the mountain, near this area here, which is called Suzerlandai, and in the Yamada watershed, which is about 220,000 square meters. So a small size watershed. So if you look at the watershed in a bit more detail, what you can see is like you have a series of steep slopes. So like I just drew roughly here a transect across one of the gullies, and you can see you have steep slopes with the rivers at the bottom. And across the slope, you can see those kind of changes, slope changes. And this here is clearly the road that you have. So why did I get interested in that question here? Well, actually, it all owes to Dr. Hayakawa, who invited me a couple of years ago to go and join him on some of his experiments, where he was checking whether walking barefoot or with different type of mountain gear was having a different effect on the ground. And of course, it does. Of course, it has a very different effect on how we modify our environment. So this is one of the main results on the right that we did together with SFM and also LiDAR data, where we measured how people walking barefoot or with different trekking shoes are impacting the environment. And from that research that he kindly invited me to do with him in Hokkaido, then I started to wonder, so what is the role of pedestrian traffic and the associated infrastructure? Because we're just not walking in the forest. People need to have actually something, most of people, like some of us, like to walk across the slope, but some other people just go for recreation. They want to have a pathway through the mountain. So what is the impact of that? And how detrimental this return to nature, our need for nature, is for the environment? And I think it's an interesting question because at the same time, people go back to nature, usually they like nature and they like the greens, they like the spaces, and they have maybe little idea that actually them crossing like in large number those areas can have negative impact. So for that purpose, I combined the LiGrip 2 PPK GNSS that you can see on the photograph on the left. It's a SLAM LiDAR system, and I put here PPK GNSS because from my experience now, you actually have a lot of drift in those technologies, but using GPS or GNSS at the same time allows you to correct the data in a very efficient way. The work we have done in other places, like at Unzen Volcano with my students, show that comparing to other data sets taken with other remote sensing methods, we have a very, very good match to a few centimeters or a few millimeters, depending on the places, if you then correct a bit more the data. So once you have it, shake it a bit to get your data out of the system. Then you get a point cloud that you can get in Cloud Compare, where you can do a lot of different manipulation that we're going to show you in a second. And in that case, what I've done is like I've used that as a boundary condition to run a simple CFD shallow water equation model to try to understand the relation between the stairs that you can see in the center and where the water is going and whether actually those structures are influencing the erosion. The other thing that I was doing at the same time, which was very time consuming, using the Yamanaka soil compression test, on the tracks and around the tracks, on the stairs and around the stairs. I've been like just taking those compression tests to see how much difference we have between the beaten track and the natural or semi-natural environment around. And when you look at one of the results I'm going to present and share with you today, if you look on the left, you can see the watershed I was showing you earlier. So when you look at this staircase here on that side, the whole staircase is about 50 meters long, and the denivellation up and down is 11.5 meters. And I've separated this staircase element, and I've straightened it. So I took the central line and I put everything straight. So it's easier to represent it on the slide, but the staircase is not straight. It's just a representation of the data here. And what you can see is that you have this center part here with the slope which is slightly slanted, so the reddish part is higher. And you have on the other side like these blue elements showing that you do have actually like pocket-like topography on those different slices. And when you zoom on it, you can see this side with all the pockets. You can see the wood rebar in between creating the different stairs. And on that side here, you have the topography, which is slightly higher. And on top of it, you have here a set of numbers. Those set of numbers are the compression tests using the Yamanaka compression. What we can see is that we have a relation which is quite interesting. When we are on the stairs, you can see that, of course, the sediment is much harder to penetrate with value between 23, 24 to up to 36. And when you're on the side, on that side here, on the true left, when you go up, there is no true left, it's the left. You have 11, 16 values that are on that side. And on the other side, where I think the water is going, you have like much lower value. Although this one 13 is closer to the value here. So lower value around, harder, larger value in the stairs than expected, and eventually a division between left and right. So that division looks like something is flowing there. And what I wanted to do is to test that idea, like just saying, oh, it looks like we have a reel here. It's good, but is the water really flowing that way or the other side? Or is it not leaving the stairs and it's just flowing in the stairs? And that's what I wanted to see. So what I did is to run a short simulation like this, where you can see the water. I have done two different type of discharge values. And here you have the water depth as well as the direction of the flow. And what you can see is that the water goes down. You have here an increase of 20 centimeters depth, which doesn't exist. It's because I start my water pooling here at the top, and I keep on putting water in it. And the water pools a bit before it goes down. The best way would have been actually to run the simulation for much longer time and see actually how the water flows with the lower depth. The result will not change, but it wouldn't look like the water is pooling that much at the top. And then it flows at first unexpectedly just on the stairs. So on that bit here, when you have the stop around here, it's really flowing on the stairs and the water stays in the middle. But when you get down to this area, which is like that flow here, area where the flow occurs, outflow occurs, the flow is diverted away from the staircase and then it's flowing on the side. And then it flows on the side. And on this bit here, you have actually kind of a fence, a concrete fence. That's why I put it. I didn't do the simulation further here. And the flow goes and bumps on that fence, and actually it flows back into the staircase. So that rail here is just local on that side, and then it doesn't flow back. It flows back on the staircase. Staircase, due to their construction actually and the foot traffic, limit the penetration of the Yamanaka, which means also that it's more difficult for the water to get in. And those pathways on the slanted slope are increasing actually erosion and inflow erosion features like the rail. So altogether, it's a very interesting, actually, anthropogenic survey and research theme, looking at the fact that human beings, even when they like nature and they enjoy actually being and going there, they have actually some important impact on the nature itself. And that's one of the things I wanted to show as a continuation of the more theoretical work that we had done with Yuichi Hayakawa earlier. Thank you very much.